So you missed lesson 5.1.1, hot in here. The first thing that we talked about were the terms correlation and causation. You may have heard the phrase correlation is not causation before. This is referring to a set of variables being related. So for example, if somebody says there was a study and it found that people who make more money are happier, you may have to look a little deeper because although there's a correlation there, there isn't necessarily a causation, a cause and effect, meaning if you make more money, you will in effect be happier. So what we're looking at is what is the relationship between the rising levels of carbon dioxide and the increasing average temperatures on Earth? Is it a correlation or a causation? And why? So in this lab, we're actually going to be taking measurements to look at this a little bit closer. So we've got a scenario, and it really talks about the environment that you're in when you're at a concert. So it says your friend Snapchats you a picture and complains about how hot it is inside the Key Arena. And you know that the human body radiates thermal energy, but you're also wondering if all of the carbon dioxide that people are exhaling in the arena and the fact that there are so many lights shining down on the stage, does that have an effect on the temperature as well? Your friend says, well, fire extinguishers have carbon dioxide in them, and so she thinks that this would actually help cool down the Key Arena. So first, as a class, you missed us writing a hypothesis. So everybody made their best guess. And it's a little bit tainted due to us already having a little bit of background knowledge after watching the Bill Nye YouTube. Okay, so then we set up the scenarios. There's a part 1, a part 2, and a part 3. First, we're going to measure the temperature inside an empty bottle, which is representing Key Arena with no people in there. And we're shining a big light, draw a little light bulb here, right at that bottle, and we're measuring the temperature inside. It's my little thermometer. And in scenario number 2, we're going to add some carbon dioxide by having somebody breathe out a little bit. And so that's going to represent before the concert starts, there's a meet and greet, there's a few people breathing. And part 3, we're going to actually add a big breath of carbon dioxide and again measure the temperature over time. So take a second, pause the video, and write down what you think our manipulated variable and our responding variables are going to be. Okay, so the thing that we're going to manipulate here is the concentration of CO2. Will it be low, medium, or high? And the responding variable that we're going to measure is the temperature in degrees Celsius. Okay, and we used lots of different materials here, but some of the key materials that you should know about are we used these carbon dioxide probes, which can measure how many parts per million of carbon dioxide molecules are present. We also used a temperature probe, like I mentioned, the plastic bottle with the top cut off. We used a big light bulb and a ring stand which kind of held that lamp in place. We had little cups to kind of seal the top off so that our probes could stick into the bottle. And we also used Logger Pro on the laptops in order to collect our data. So just to draw a more thorough sketch of what this looked like here, we've got a big light. Here's my light bulb inside, shining, and here's my bottle. And maybe we'll put kind of a picture of the CO2 sensor, which is connected to the laptop. And the key thing was to keep the distance consistent between the light and the bottle, because obviously if you have the light closer or further away from the bottle, that's going to be a pretty significant change. So we collected data again for the lowest CO2, which was no breath inside. Then we did the same thing where we had a small breath of CO2, and a third trial, oops, that was in the wrong spot, medium CO2, and a third trial with a big breath of CO2 in the bottle. And we did measure the parts per million. The level of carbon dioxide just naturally inside the bottle is about 400 parts per million. And then procedure 2 and 3 here really depended on how big the person's breath was. So this one could have been around 5,000 parts per million versus the highest concentration was maybe 15,000 parts per million. And so you're going to use the data that is in the absent student data, and when you open that up, it's going to look like this with the lowest, medium, and highest data. And notice here I've got 2 trials. So the first thing you're going to be doing is figuring out the average of your 2 trials. And so the way that you can do that is type an equals sign and then type average and do a parenthesis. And then you can highlight the 2 numbers that you want to average, do a close parenthesis, and hit enter. And then if you click on that box, you'll see a tiny little square pop up in the lower left corner. And you can click that and drag it all the way down. We want 50 seconds. So again, this is in the empty bottle over a time period of 50 seconds. This is what was happening to the temperature of the air inside the bottle. So it went from about 22, was it, to 28. I guess 21 and a half. So I'm going to do the same in my tab with the medium data. Equals average. Highlight my 2. Click on the box and pull it all the way down to 50 seconds. And highest CO2. Equals average. And then I'm going to take my data and pool it all into one sheet to make it a little bit easier to grab and make a chart out of it. So I want to have time versus the lowest CO2, the medium CO2, and the highest CO2. So I'm going to go over and call this, if I double click on the sheet name, I can call it combined data. And I can click and drag my sheet so it's off to the end here. Oops. Okay. And then I'm just going to copy and paste the 0 through 50. So I'm going to do Control C and I'm going to hit Control V to paste. And then I'm going to go to my average data and I'm going to hit Control C. And this gets a little tricky. If I right click, I can choose to paste the values, because otherwise with the average formula sometimes it gets a little bit messed up. And then I'm going to choose my medium data, Control C, Control V. Oops, that didn't work. I'm going to right click and remember to click the values, paste, so that otherwise that'll be very different. Again, I'm going to do Control C, and for the combined data I'm going to right click and click on the values. So now I'm ready to make my chart. So I'm going to highlight all of my data and I'm going to click on Insert, and I want a scatter plot, and I want the one that has lines on it. Once I've got that, I want to go to Quick Layout and choose the upper left, because that one gives me some titles to work with. And I can play around with this, make it a little bit bigger if I want so I can see it. I'm going to create my title first. I was measuring time versus temperature with varying CO2 levels. I can also make my too small by highlighting it, right-clicking, changing the font to subscript. I can change my axes titles by clicking on them. We have temperature in degrees Celsius. And going across the bottom, this was over time in seconds. I'm also noticing that since my axes, since it's stopped at 50, I can right click, and instead of going to 60, I can make my maximum 50. Also here, I'm noticing that my minimum could be 20 to spread this out a little bit more. And I don't really like the colors, so I can go ahead and click on the lines and click on, let's see here, maybe there we go. Let's see if I can right click on here, format my data series by changing the colors here. Marker, I can fill it a different color. Maybe I want the top one to be red. And maybe I want my middle one to be green. My marker, green here. And maybe I want my bottom one to stay blue. Also, if I click on the line, I can right click and add a trend line. A linear trend line, display my equation on the chart so I can see my slope. I can click on the next line down and add a trend line again and display that one's equation on the chart. And I can do the same for my last one here. Oops, wrong thing. Add trend line, display equation. So you can see the slopes are increasing as the carbon dioxide level increases as well. So after we made the charts, everybody pasted theirs into OneNote, so you can do that. And take the time to go ahead and work through the questions on your own. And one of the questions has a little bit of algebra in it, so just do your best to work through that. And there's a conclusion to write, citing your evidence, and discussing the reasoning. And then the homework was to also finish the 2 making sense questions. So that should give you a good start to what you missed on that lab.